Assalamualaikum. Hi guys. In this video, we are going to continue about first ionization energy. Last time in the previous video, we've learned that the general trend in first ionization energy, when we go down the group, the first IE decreases, while across the period, the first IE increases. However, we should understand there is a special case for the variation in the first ionization energy across period 2 and 3. You can see here there is a big fluctuation between beryllium and boron and nitrogen and oxygen in period 2, while between magnesium, aluminium and phosphorus sulfur in period 3. So we are going to discuss why there is fluctuation along this trend. Because generally, we understand first IE increases across the period, but why here it decreases? Let's find out. So this is what we call as anomalous behavior for the first ionization energy. We can see the increase of first ionization energy with proton number is not uniform. Kalau dia uniform, dia akan keep on increasing tanpa ada penurunan. Tapi kes sekarang kita boleh lihat yang saya bulatkan ini, dia ada penurunan. Sedangkan kalau uniform, dia akan keep increasing with a straight line. So you can see first IE for beryllium is higher than B, boron, ataupun IE for nitrogen is higher than oxygen. Ini untuk period 2. Dan untuk period 3, awak boleh lihat antara magnesium dengan aluminium dan juga phosphorus with sulfur. So these irregularities kita akan explain based on stability of half-filled and fully filled orbitals. I hope you still remember last time kita belajar half-filled and fully filled by using orbital diagram, which is more easier to look at. So, let's talk about these types of orbital. Untuk fully filled, it is the most stable, while untuk partially filled orbital, it is the least stable. So, for example, we talk about ionization energy for beryllium and boron. So this is the electronic configuration. Kalau kita write in SPDF notation, awak tidak akan nampak macam mana bilangan unpaired electron in their orbital. So that's why I'm going to draw the orbital diagram for beryllium and boron. So as you can see here, based on their orbital diagram, more energy is required to remove electrons from beryllium, because the valence electronic configuration for beryllium is 2s2 due to highest n value n equals to 2. Why is this happening? Because 2s orbital in beryllium is more stable due to fully filled orbital compared to partially filled orbital in boron, which is 2p orbital here. So electrons in 2p orbital of boron is very unstable because we only have one unpaired electron in 2p orbital. Hence, it is very easy to remove. Hence, we can conclude that IE for beryllium is higher than boron because electrons will be more difficult to remove for beryllium, which is in fully filled 2s orbital. Next, kita lihat untuk nitrogen dan oxygen. I will draw to you the orbital diagram for nitrogen and oxygen. So as you can see here, more energy is required to remove electrons from nitrogen. This is because nitrogen, we have half-filled 2p orbital. So half-filled 2p orbitals of nitrogen is more stable compared to partially filled of 2p orbital in oxygen. So, dua electrons in 2p orbitals of oxygen experience considerable mutual repulsion kat sini. So, yang ini yang saya maksudkan. That's why it is easier to be removed. Hence, IE for nitrogen is higher than oxygen because nitrogen have half-filled 2p orbital here. Difficult to remove the electrons in it. Same goes for IE in period across period 3. For example, I compare between aluminium and magnesium. So let's draw the orbital diagram. So as you can see here, more energy is needed to remove single 3s electron in magnesium. Ini kerana 3s orbital dalam magnesium adalah fully filled orbital. Jadi untuk remove electron dia agak susah dan kita perlukan energi yang banyak. Compared to aluminium, aluminium kita ada 3p. 3p orbital in aluminium is partially filled. That's why this one electron from here is easier to remove. Jadi less energy. That's why IE for magnesium is higher than aluminium. Same case happen for sulfur and phosphorus. The first electron yang awak nak remove daripada sulfur comes from 3p orbital, which is this part. Dan dekat sini kita nampak ada dua electrons yang mengalami considerable mutual repulsion. Jadi, senang untuk kita remove dia berbanding dengan phosphorus yang mempunyai half-filled 3p orbital. That's why IE for sulfur is smaller than phosphorus. So, I hope you can understand macam mana kita explain anomalous behavior for the first ionization energy across period 2 and period 3 berdasarkan stability of DR orbital. The stability can be fully filled, half filled ataupun partially filled orbital. So look carefully based on your electronic configuration, and I hope you can answer well in your exercise. So that's it for this video. I will see you in the next one. Bye!